I just invented it a second ago. No idea. Okay. All right, so good afternoon, everyone. How are the things? I hope that you are excited as well as I am. My name is Maciej Kraskiewicz, and I was asked to be a host of tonight's event. So welcome, everyone, both offline and you guys there online. Today we will have two meetings, two presentations on our first Java meetup by ŁÓDŁ in Poland with two presentations. The first one is, by me about the graph databases, while the second one will be made by Wadzim Kapczenka, who will show us how Kotlin shines in synergy of its features and libraries. Between those presentations, we will have a short coffee break or cola break, something like that, at 10 to 7, and at 10 to 8, I think, 10 to 8 we will have a small after party. But before we start, I would like to inform everyone that we prepared small tiny prizes for those who will ask the most interesting questions. So please keep it in mind during the presentations and the Q&A sessions. Both people who are here and you guys online, because we will find a way to deliver it to you. All right, so I will start first. It will be a bit challenging to be the host and the presenter at the same time, but I will try my best. Okay, so introduction to the graph databases. I hope it will work. Yeah, it works. So, one more time, my name is Maciej Kraskiewicz. I'm a software engineer. I work in ŁÓDŁ since, September 2021. So, not quite a long, but very intensive time. I love hiking, skiing, sailing, but apart from those more, active sporting hobbies, I love fantasy, I love board games, and of course coding, right? You can find me on social media or, just send me an email to my ŁÓDŁ mailbox. Okay, so at the beginning, what is going to happen on my presentation, during my presentation? At the beginning, I would like to tell you what exactly graph is, right? Then we will switch to how it differs from the relational database, because all of us probably know what is relational database, because, that's quite obvious. But there are many differences between those kinds of databases. Graph database is NoSQL, but it differs from, for example, document NoSQL databases, and I will highlight all of that during my presentation. The types of graph databases, because, there are lots of relational ones, and, graph is not worse, right? Then we will get our feet a bit wet, so I will try to live code something, and then, where we exactly should use them, and I will cover it as well. I would also like to, underline that in no way I'm an expert. I just thought that graph databases are quite interesting topic and worth presenting, so that's why I'm here. All right, so databases, right? When we create an application, we are using databases, or, at least we should, right? All of us know the relational databases. They're called relational because they store the data in a sequence order. I mean, they create tables, rows, which are connected via relations, right? But that's not all. We've got NoSQL databases, like, document databases. I don't know, MongoDB, anyone? Right? Do you use it? Yeah, sure. So it differs from the relational ones because, the data is stored in documents or key value pairs, but there isn't relations between them, right? I mean, you could mimic it, you could write IDs and so on, but the idea here is that because of that, we store the data in the documents. Well, the processing of queries, for example, is much faster. The velocity is the very good feature of the document databases. But, well, it's not the only one, right? It's not the only one type of the NoSQL databases, as you can conclude from the, topic of my presentation. I present you the graph database, right? So graph database is using the mathematical structure, graph, obviously, and it stores information in the nodes or the vertices. Well, it's the same name, it's the different name for the same thing, and in the relations. And the idea here is that in the database, we store both nodes and both relations, and we store them physically together inside the database. And because of that, what's important, and I will underline it at least twice during this presentation, the access to the data is as fast as access to the relation. Okay, and that's where the graph database shine. So if we would like to have the connection and access to relations, not only to the data. But a small slide for those who took a nap during math classes. So what exactly is graph, Maciej? So here I am. What is graph? Graph is a data structure which is built on, nodes, the vertices. So what exactly is a node vertex? Well, I could say that it's a data container. So we have got many data containers. Those are those blue bubbles here. And they are connected with edges, with relations between them. And the graphs are divided on, two types maybe, the directed and non-directed. So the non-directed are, like that you can see here. So the both nodes are connected symmetrically. So I can go from that node to the node B, from the node B to the node A, and doesn't matter. The directed ones are a bit different. I mean, imagine that here we have got an arrow here. So from node A to the node B. And we can go from that node to this one, but we cannot go back. Unless we've got another relation from node B to the node A. And in practice, most of the graph databases are using directed graphs for their purposes. Okay, but I mean, some of you may say, Maciej, but we've got the relational databases, we've got a MongoDB or other NoSQL databases. Why the heck do we need something more? I mean, I'm using those databases, that's enough, and I don't want to learn something more, or maybe, I don't know, it's too complicated and so on. I mean, all the problems could be solved using the databases I mentioned. And you would be right. But in some cases, graph databases are better. So the point is that it's nothing new, totally. The graph databases started being used at 90s, something like that. But later on they fizzled out because most of the problems developers had could be solved using trees, right? Well, that was true. However, because the internet became more and more popular, we had much easier access to the internet. Because of that, the amount of data around us, Wikipedia, those eBays, all social networks started to grow rapidly. And both data and both relations between those data. And to solve that problem, people went back and started using graphs one more time. And I would like to mention about one presentation made by Neotechnology at 2009. They've made a social network, okay, so their own Facebook or Twitter or anything, which had 1,000 users. And each user had 50 friends or colleagues or mates. And they created a representation in a relational database and in graph database. And what happened? When they made a query to, print or return all the users or the people inside that database and all the friends of him, so 50 people per one person. It took 2,000 milliseconds to fulfill the query. And they did the same in, graph database, and it took 2 milliseconds. Okay, so, the difference is quite big, but that's not enough, because they've multiplied the number of the users by 1,000, so 1 million in total, if I calculate right, and they made the same query, and it still took 2 milliseconds. And I think that's a good example on where we can use graph databases and why they can be better, right? But, as I said before, we have got few different types of graph databases. I would like to focus on two of them. This picture is, taken from the official Neo4j webpage. We have got here a statement. So, connection between New York City and San Francisco. Fair enough. The cost of the connection is $300, and the distance between those two cities is 4,100 kilometers. And we have got two representations. One is LPG, for example, by using of the Neo4j, so labeled property graph. And the other one is RDF, so resource descriptive framework. I didn't change the picture from the website, but we could use SparkQL in that case. In case of RDF, we are having triples. It's based on triples of subject, predicate, and object. And the subject is, in that case, it would be the connection between San Francisco and New York City. So it is a node, a vertex. The predicate connects the subject to the object. So it's the edge, like from where the connection comes to, or what's the distance, or to where it goes, right? And the object could be a node, so for example, a city, New York City, or a literal value like, the number of the kilometers, okay? And as you can see, everything here is described by URI. So why it's that? Because the main idea of the RDF is to expose data or to exchange data. For example, the Wikidata API, right? It gives the information stored in the RDF database, and you can search for, almost everything. I was trying to do some searches for books, and, you can find all the books written by the author who died because of lung cancer. No problem, right? The LPG, so the labeled property graph, is a bit different because it tries to represent the statement in as most logical way as it can. So, for example, here we have got, node, New York City, a second node, San Francisco, and a connection between them. And please take a look that the connection have got the properties, right? So it's not just relation between those two nodes. The connection has got its own properties. And that's because, I will say it one more time, in graph databases, both connections between the nodes and the nodes are stored physically in the database. And for the further slides, I would like to focus on the labeled property graph, maybe because it, looks more logical to me. Okay, so we've got a node, we've got a relation. I've used, Fellowship of the Rings because, as I said, I love fantasy. Each node has got a label, right? And, member or team, and each relation has got a type. Both type and nodes have got the properties. So the thing to remember, another thing, is that we can have a node who's, alone, but we cannot have a relation which is alone. Relation has to connect to nodes. Okay, so relation cannot exist without the nodes which it connects. And, I think that it's enough for the theory because, you know what the graph is, you know what's the difference between the relational and graph databases, And the best way to get to know with a new technology is to, well, see how it's, well, done or coded, right? For the purpose of my small presentation, to get our feet wet with it, I will use the Neo4j, which I mentioned twice in the presentation. It's an open source written in Java, but, well, of course, you can use it in any project using any other language, but you know, we've got a Java Meetup, so it's written in Java, hey, right? You can, well, call the API, which has got HTTP REST endpoints, and that's all. Okay, so I will try now to prepare well, a database. I hope that it won't need to be, oh my god, it needs to fire one more time. I'm using Neo4j sandbox. What's interesting here that if you would like to, well, see what's going on, try to code something by yourself, you do not need to install it locally. You do not need to pull the Docker. Well, you can just go to the Neo4j sandbox, register, and, well, try to do something. Unfortunately, it's firing a bit long, so maybe I have to tell an IT joke. Do you know? Oh, you are safe. But maybe I will try. Do you know what's the way for the Java developer to become wealthy? Use inheritance. Okay, so right, we've got an empty database, right? So let's try to, well, fill it. First of all, we need to create nodes, because the nodes can exist without relationships, but vice versa, it doesn't work. So let's make a node. Let's call it team with properties like I hope I won't make some well, mistakes, because I have to watch both screens. Oh my god, okay. What's going on? Oh yeah, thanks. Yeah, it's hard to, you know, watch keyboard here and screen there. Okay, so I created one node of a certain label. Now I will create some more. This time it will be called member. Yeah, unfortunately, again, Lord of the Rings. Sorry for that. I think it's 140, not sure. But to be honest, we don't need, well, ID here, right? Because it's a NoSQL database. Okay, so now I will cheat a bit to make things faster. He was a bit younger. Well, I know that okay, I know that he wasn't exactly a human, but well, just for the purpose of the presentation. All right, so we created 3 nodes, and now let's check what's inside the database. Okay, so we've got those nodes. We've got a nice UI with the nodes we can play around, right? But it's not all, because we need to somehow connect them, right? So we are creating a connection. So to make a creation, I need to match 2 nodes to connect them together. So I need to create a, well, connection between, for example, a member, right? And a connection to the team, right? And I'm using a where clause, and where, for example, member first name is equal to Gimli, and team full name would be Yeah, and then if I will match those two nodes, I will create a, well, relation. And that relation will be from node M, so member, with a relation belongs to, and of course I can add a property here, right? And it will point out, and you can just see that I'm just using an arrow, and the arrow from A is pointing up to the, well, node T, right? Oh my God, where have I made a mistake? Team, team, what's going on? Oh my God, maybe I will just use a prepared script just to make it faster. Oh my God.
Maybe missing space between
No, it shouldn't be missing space. Maybe I will use of course, always something has to go wrong during the, well, live presentation, but as usual, sorry for that. If it won't work, yeah, okay, so you know how it's going on with the live presentations. So I will just make it faster and recreate it. Oh well, happens, right? Okay, so now, because in the relational databases, we connect the information from different tables using join, right? For example, well, select member, hero ID, team number, and so on. In graph database, the relation is stored together with the data. So we do not use any joins. And in this case, if I would like to get the data I've stored at the moment in the graph database, I could use just a match with a member, which is, well, connected by a relation called belongs to the team with full name, the full name fellowship of the ring, and I will return both members and nodes. Oh my God, what is going on? I'm doing something.
Like full name is...
Or maybe maybe I've made a mistake with the full name.
Mm-hmm. When was created?
What's going on here? Oh my God. Yeah, maybe we will skip it for now, and then I will just use some more plays with here. Okay, so the idea here is, unfortunately, I don't want to take too long time to see what's wrong. The idea here is that, for example, here I've used this query, which is setting a new property to a node with, well, in this case, it's hero ID, because I've used a pre-made script. And if we will take a look here, we will see that, well, the node called Gimli has got a weapon, X, while, well, Aragorn and Boromir, neither of them hasn't got it. And it's worth noticing that, well, it's not null. I mean, they don't have a property called weapon. It just doesn't exist here. And that's the similarity to, well, the MongoDB and document NoSQL databases. Okay, now I will just, well, delete those unfortunate nodes. And I will prepare something bigger. Just don't, well, write it and type it down. Because creating those nodes is, I mean, you would have to create a few nodes and make some relations between them. Well, it would took a bit more time than I expected. So imagine that, well, we have got a problem where we could use graph database. It's, well, example, I didn't invent it myself. I just found it and changed it a bit because I love hiking. And you can see here, well, the landmarks and the routes between those landmarks. Okay, and if you will focus on it, you will see here a graph. So those are nodes, okay, while the routes between the nodes are just relations between them, okay? And of course, for example, we've got an application which, well, gives some information to the people who are hiking in the mountains. And we could use a relational database here, okay? So a very simplified, database would look like that. We've got a route table with ID and name, we've got a landmark table with an ID and name, and we've got an aggregation table with, well, route ID, landmark ID, order number, and the name of it, okay? And the data we would have could look like that. So we've got here, well, two routes, route number 1 and route number 2. We've got here order number and landmark ID. So starting from landmark number 1, we could go to the landmark number 2, 3, and 4, going by the route number 1. Or we could start the route number 2 from the landmark number 1 to go to landmarks 5 and 6. As you can see, the orders are depending on the route, okay? And let's imagine that we would like to show on which routes is lying a certain landmark. So, well, the query wouldn't be very long. We would just make a, you know, select route name from routes with two joins, joining, well, aggregation table and the landmark table, okay? But what if someone started the route, his journey, here, and we would like to sleep in the shelter, mountain shelter in Petetekeile-Skowiec, right? And he wakes up and he wants to go further the next day. And he would like to know where can he go starting from that point. So not from the beginning of the graph, but from a certain point. And here's the moment when the things are getting complicated because, well, we have to firstly select the, well, the certain route or routes. Then we have to select our landmark from where we start. And all the landmarks which order number is lower than the landmark from which we started. So yeah, it looks a bit more complicated. And could we do with that problem something in a graph database? And yes, we could. So in case of the first one, in case of the first one, we could. What we could do? We could make a match which will be fulfilled by a landmark which is named under Paulusowa mountain, right? And, well, is connected by a relation of type route to another landmark. And then we will like to have the relation name. And, well, it's a small query in a size comparable to the SQL one, but what about the second one? I would like to remember you how it looks like that, okay? And now we will do it in the graph database. In the graph database, we can achieve the same goal using this query. what that query do? That query is, well, matching the landmark, which is called crossing at the hatch root, with, well, the roots, connection root, with another landmark. And that star here means that if another landmark is connected by a relation of, well, type root, it will be returned as well. So, well, maybe a recursive function, something like that. And I will just add here a landmark as well. Okay, cool. And now let's make it bigger. And here we have got, well, where it is. Yeah, here is our starting point, where it is. It's a Hertz root. Yeah, it's this one. So starting from that point, we can go to all those. And if I would return the whole graph, we will see that that point is, well, here, so not at the beginning. Okay? But of course, those are very, very small problems, and we could do, well, much more. I will try to open a pre-made database using pre-made data. It's called movie database, and it consists directors, actors, and you can just create it by clicking in a sandbox. But before it will load, not to waste, well, more time. Oh, it loaded, okay. So not to waste more time, let's see how it looks like. Okay, yeah, it's bigger, and if, whoa, it's bigger, and if I would try to load it during the presentation, it would take a bit too long. And what can we do here? Well, for example, we could get, I don't know, someone likes Tom Hanks? Maybe. So we could match a person, Tom Hanks, okay, and get all the movies in which he acted, and search for all the people who acted in the same movie as Tom Hanks. So we have got one node, another node. Both of the nodes are related by acted in with movie node. And those are all the actors who played in the same film in which Tom Hanks played. Okay? But we can do more. As far as I know, well, Matrix is a trilogy, but maybe no, maybe this one would be better. So in this case, we are searching for people who are somehow related to movie The Matrix, and we will return the people name, the person name, the type, how he's related, and, well, whole relation. So here we can see that Emil Efirman is, well, he acted in Matrix. Joel Silver is a producer, Lana Wachowski directed it, and so on, and so on. Of course, we can not only play with the, well, return values like here, but we can modify the graph. For example, Tom Cruise, if someone likes Tom Cruise, we can get a Tom Cruise-centric graph, so he will be the heart and the center of our graph, right? In this case, I'm searching for the node of Tom Cruise, and I want to get all the nodes which are up to 3 hops from Tom Cruise. So from Tom Cruise now I can go anywhere up to 3 points. 1, 2, 1, 2, 3, and so on everywhere. Even, and that's funny thing, even if we are, well, creating a graph database, we may even not think about it, how the nodes can be connected to each other. So in my example, it would be, well, Liv Tyler and Meg Ryan. I don't know if you have got any idea how they are connected, because I hadn't got, I didn't know how they are connected. So, all right, we are writing the shortest path between Liv Tyler and Meg Ryan, and let's see what happens. Okay, so it seems that Meg Ryan starred in You've Got an Email, and it was the film where Tom Hanks acted. And Tom Hanks acted and directed. I don't know what that film is. That Thing You Do, I don't know if you know that film, where Liv Tyler acted. And yeah, so we found a path from Liv Tyler and Meg Ryan. And that's the funny thing, that when we create a graph database, we can have the relations we even didn't thought about, right? Like Liv Tyler and Meg Ryan. Okay, so to sum up a bit, what exactly is the purpose of graph databases? So we can use them in, well, classical applications. So all the applications where we use relational databases or MongoDB or other document ones. But they shine really bright in the complex networks. So for example, social networks, right? As I mentioned at the beginning, the experiment by Neotechnology, where the node is a person, a team, and the relations are who is a boss of whom, or who is a member of which team, and so on. Information networks, so, well, Wikidata API, or hyperlinks, or quotes to the articles. Biological networks. I mean, I'm not a biologist. I've got friends who are, but I'm not personally. And most of the things in the biology, I hope, or I think maybe, are represented by networks. So yeast metabolism, or protein to protein, or gen regulatory, all that stuff, networks. And you can present every of them in the graph database. Technological networks, so spatial and geographical stuff, like air pathways, or, well, mobile networks, you name it, right? And in every of those examples, graph database will work better, faster, and more effective than the other solutions. Okay? Right, so that's all I think I've prepared for today. I hope you enjoy it. I prepared a small bibliography, sorry. Always have a problem with spelling that word. Unfortunately, most of the positions there are in Polish. Some of them are in English, but if you would have any problems, you know, just contact me and I will try to help you as much as I can. So, if you have got any questions, just ask me. Remember that I'm not an expert. As you can see, there was some small problems, but we've managed them. But I will try my best if you have got anyone or any questions. Yeah?
First of all, thank you for your presentation. And you mentioned like an advantage of that speed.
Yeah.
And what is the disadvantages, main disadvantages of using graph database, and maybe it is too complicated in implementation, some other stuff?
Okay, so you're asking me in which cases the graph databases do not work as well as relational ones.
Maybe in this way.
Okay, so, well, the idea is that the graph databases are the databases which should somehow represent the structured data. Okay, so the nodes are the data containers, there are relations, and, well, not exactly everything have got such a network structure. If, I mean, you are using working for some big corporations and you are making the crude applications all the time, I think it's totally not worth the effort, right? If you are, I mean, the idea of the graph databases and the places where they really shine is the ones where they can represent networks. So in my example, it would be a hiking. You know, everything is connected to everything. And I don't know, I'm working on a stagecoach project, right? So we have got buses in Great Britain. So if you have got buses, bus stops, I mean, in that cases, you will also write much smaller queries than in the relational databases. But if you are creating just a normal CRUD, or you are working on a very big text documents, for example, I don't know, for libraries, or I don't know, stuff connected to the newspapers, where there are a lot of big data, that you've got blobs and so on. It's a not good example for the graph database usage.
Cool, thank you. And like a second question in a row, sorry. You mentioned that if we are selecting something like a database, you showed a SQL script, yeah, for selecting the same. Do you have an experience of what time we will need to migrate? For example, we did a mistake. We selected another one database type, and we need to migrate to.
I mean, you migrate the whole graph.
To a graph, or from graph back to usual databases. Do you have such experience?
Okay, so unfortunately, personally, I don't have that experience. I was working mostly on the RDF ones, and we were just using the Wiki API database. I mean, what I've checked, you can, well, create an embedded graph database, so you can work on it not using, for example, Neo4j endpoints, but you can just write a, I don't know, migration tool in the Java code to just try to migrate it from the relational database. I mean, you are creating the nodes with certain properties which are the same as the ones in the relational database. So maybe something like that, but well, I don't want to misdirect you somehow. That's what I would do with my current knowledge about the graph databases.
Cool, thank you very much.
Yes?
Alright, so my question is maybe similar to the first one. What is the trade-off? Because you mentioned that the graph database is much faster, more efficient, like 2 milliseconds versus 2000 milliseconds, but what about the size of the database? Because you need to store also the connections?
Okay, so the idea is here that in that particular example, because we had so many users, all of them are related somehow. Well, in that case, it was much faster. And as I said before, it is faster when it represents a network. The biology ones, or those air pathways. And in that case, it's faster, even if it has got much more data, because it scales easily. But only in that case, because you may say that, okay, Maciej, that's cool, but we have got indexes in the relational databases, so I will just bam, make index for everything, and results is getting like the Chinese soup. Just put water and bam, we've got it. And I will agree with you, but well, the problem is in that case is because we are using indexes to make it faster and more efficient in relational databases, that if we would like to change something or add something new, it's well taking a lot of time and a lot of efficiency. So if we are using a lot of indexes, like we would have in the graph database, because we have got a lot of properties and you can search it via writing the queries in the cipher, we would be faster in a graph database. So if there are problems, the network-like problems, it's faster. If we would have just a typical problem with the product and a description of it, and that's all, we do not have many connections between, I mean, we've got one table which has got, I don't know, the product and the price and the storage, something like that, and nothing more, and those storages aren't connected to something else. It's not worth effort to use a graph database. And I think that the speed would be then quite similar to the relational databases, or even lower, in my opinion. Someone else? I don't know if people are, sorry, okay?
Hey, I would like to ask about transactions. So traditional database has transactional, and
Yeah.
add data in one transaction. Do you have something similar in graph database?
I mean, when I was taking a look on the information from official Neo4j Docker, it got almost everything the relational databases are providing. So, well, test containers, embedded databases. To be honest, I didn't check about the transaction, but I think that it's so obvious that it needs transactions that it will have it. I may, after the presentation, just take a look and contact you to check it. But honestly, I'm almost 100% sure that it well provides. I mean, I think that when I was using SparkQL for the RDF databases, we were using transactions. We couldn't not use it. So, but it was a few years ago. So I don't want to, give my head for it. Not sure if someone online have got any questions. Seems that not. Right? Okay. Because I don't know if someone is checking. Okay. So if no one have got any questions, both offline and online, I will just say, well, thank you very much. My name was Maciej Kraskiewicz, and it was the presentation about graph databases. And well, now after a very hard presentation, to get your batteries reloaded, I would like to invite for a small coffee break. I am putting it in braces because we've got a lot of stuff aside coffee. So be our guests, and for those who join us online, please stay with us because we will be back soon. Thank you very much.